for first four cases for that. Okay, so this is case one if a function is e raised to ax. Okay, and we just discussed a lot of things about that. Okay, and then after that, uh, the second case if fx is sine ax plus b or cos ax plus b. Third case is sine hyperbolic ax plus b or cos hyperbolic ax plus b. And the fourth case is for x raised to m. Okay, so we have seen the examples related to all that cases also to understand it in better way. Now today we will discuss what is the fifth case. Suppose if my fx is equal to fx is of this type e raised to ax into v. What is v here? Where v is a function of x, function of x. Okay, so it may be sine ax, it may be x square, it may be cos x, hyperbolic x, whatever that. Okay, so it is a function of x. Then how we can find out the particular integral for this? Okay, so yp is equal to 1 upon phi of d into e raised to ax into v. So what we need to do here, so let us see it properly. See, we just take this e raised to ax outside and replacing d by replacing d by d plus a. This is very important, into v. That's it about this case. Fine. See, in the fifth and sixth, from fourth case, there is no case of failure. Okay, so just keep in mind. Uh, we just take this e raised to x outside in this case, and we are replacing d by d plus a. Replace d by d plus a. See, a is if a is negative, then we are replacing d by d minus a. Okay, whatever a, positive, negative. Okay, suppose if a is equal to minus 2, then we are replacing d by d minus 2. If a is plus 2, okay, then we are replacing d by d plus 2. This is the difference between both. Okay, so whatever the value of d, whatever the value of a, we just keep this value, we just replace that value. Okay, here. Now let us see the example to understand this. Suppose if I have b square plus 1 into y is equal to e raised to 2x into sine x, suppose. Okay, then how to find out the particular integral for this? Suppose here d square plus 2 instead of d square minus plus 1, so this is 2. Okay, now what is yp? Yp is equal to 1 upon d square plus 2 into e raised to 2x into sine x. Okay, so what we need to do here, we need to replace this d by d plus 2. What is a here? A is 2. Okay, so replace d by d plus 2. Okay, so see what I get here. So this is equal to 1 upon, see this, keep this, take this e raised to 2x outside, its work is over. Okay, once if you are replacing d by d plus a, the work of e raised to 2 is over. We are not involving that e raised to 2x in further calculation. Okay, after replacing d, so this is nothing but d is nothing but d plus 2 square plus 2 into sine of x. Are you getting this? Okay, so just we are replacing d by d plus 2. This is equal to e raised to 2x as it is. Now expand this. What is the expansion of this d plus 2 bracket square? We have the expansion actually. It is what? A plus b bracket square is equal to a square plus twice ab plus b square. Using this expansion, just try to expand this. What is this then? D square minus 2d, sorry, minus 4d. It is 4d plus 4 plus 2 into sine of x. Okay, so hope you have got this. And then what I get here, simply this is equal to e raised to 2x 1 upon This is d square minus 4d plus 6 into sine of x. Now replace d square by second case, sine ax plus b. Okay, the work of this e raised to 2x is over. We are not taking this e raised to 2x into consideration in the further for the further calculations. Okay, we just think about 1 upon 5 into sine of x. Okay, what is that? A here 1. Replace d by, replace d square by minus a square. Second case says that. Okay, case number 2. Case number 2 says that if function is sine ax plus b, then replace d square by minus a square. What is a? A is 1. So here a is 1. Its square is 1 and multiply by minus. This is minus 1. Okay. So therefore what I get? E raised to 2x 1 upon, this is d square replaced by minus 1. So I am replacing this d square by minus 1. Okay. Minus 4d, keep this d as it is. We are not replacing d, we are replacing only d square. Okay, into sine of x, isn't it? Now minus 1 plus 6 is nothing but plus 5. Okay, so therefore what I get here, this is equal to e raised to 2x 1 upon, this is minus 4d plus 5 into sine of x. Okay, so now this can be written as, we can write this as e raised to 2x into 1 upon 5 minus 4d sine x. And just rationalize this. We have seen how to solve this, how to get the d square in the denominator. Okay, so this is e raised to 2x 1 upon, this is 5 minus 4d into 5 plus 4d divided by 5 plus 4d into sine x. Okay, so in this way we'll get the d square in the denominator, because we have a plus b into a minus b. This is equal to a square minus b square. Okay, so this is my a, this is my b, a minus b, this is my a, this is my b, a plus b. So therefore finally e raised to 2x, it is 5d, 5 plus 4d in the numerator, divide by 5 square is 25 minus this 4d square is 16d square into sine of x. Now we have a d square in the denominator. We just simply replace this d square by a square. So replace d square by minus 1 minus a square. Okay, so therefore what I get, this is e raised to 2x, then it is 5 plus 4d into sine x is multiple with this bracket, divide by 25 minus 16 into minus 1. Okay, replace this square by minus 1. Minus minus become plus, and just take the multiplication of sine x with bracket. So e raised to 2x 5 sine x plus 4 into d of sine x. D of sine x means derivative of sine x. It is cos x. And 25 plus 16, it is what? 5 plus 6, 1. I think 41. Okay, so this is 41. Check for it. And then finally we have the final answer here. So this is yp is equal to e raised to 2x in bracket e raised to 2x upon 41 into pi sin x, and derivative of cos sin x is cos x plus 4 cos x. That's it. This is my answer. Okay, is there any doubt in this answer? Yes. Okay, so I have intentionally I have just increased the number of steps. Okay, so this is only 5 to 6 step answer, but for your understanding I have increased the number of steps here. Okay, so just keep in mind, don't think that this example is so lengthy. Okay, so this is very short example, but just I have increased the number of steps to understand it properly. Okay, so this is about the fifth case. So if we replace this d square by d plus 1, we'll get this answer. Okay, so e raised to x into v. Now the Sixth case is, it is quite simple. It is somewhat similar to this case, okay, but slight change is here. So suppose if my function is fx is equal to x into v, only x, there should not be a power of x, okay, x square x cube. If it is there, then we cannot use this case, okay. Only x into v, where v is what, v is again a function of x, any function of x, okay. So where v is any function of x, then how I get this particular integral for this case, okay. So my yp is equal to 1 upon phi of d as it is into x into v, okay. See what happening here. So this in bracket x minus phi dash of d divided by phi of d into 1 upon phi of d into v. So this all thing you have to simplify, and then you will get the particular integral for this, okay. Again it is very simple, just don't get confused with so many things are here and how I get the particular integral. It is simple. So let us see that. Example for this case, find the particular integral for d square plus 1 into y is equal to x e raised to x. See, both the cases you can use here. Either you can use the fifth case or sixth case, because for fifth case what we want, e raised to x into v, and e raised to x into x is here. X is nothing but v. Okay, you can use fifth case also, or you can use sixth case also, because x into v is there. X v is nothing but your e raised to x. Okay, and therefore what is my yp in this case? So yp is equal to 1 upon d square plus 1 into x into e raised to x. So use this case, sixth case. This is equal to x minus derivative of phi of d. What is the derivative of phi of d? Derivative of d square is 2d. Derivative of 1 is 0, therefore only 2d is there. And d square plus 1 into 1 upon d square plus 1 into phi of d into e raised to x is there. That's it. Okay. Now for this, we will use the first case. What it says that replace d by a. Okay, replace d by a. In the first case, if e raised to x is there, we are replacing d by a. What is a? A is 1. Okay, and therefore here this is x minus 2d divided by d square plus 1 into 1 upon 1 plus 1 into e raised to x. Okay, so what I get here, so this is x minus 2d divided by d square plus 1 into 1 by 2 e raised to x, like this. Now 1 by 2 is constant, take it outside. 1 by 2 is outside. Take the multiplication of e raised to x with the bracket. X into e raised to x is x e raised to x minus 2d divided by d square plus 1 into e raised to x. Okay, so now one more time, what we have to do, we just have to replace this, use this first case for this part. Okay, again replace d by a. Okay, so case says that replace d by a, sorry, not d square, replace d by a means 1. Okay, therefore this is equal to 1 by 2 as it is, x e raised to x as it is minus 2d divided by, we are replacing d by a, d means 1, d square is 1, so 1 plus 1 into e raised to x, isn't it? So this is equal to 1 by 2 x e raised to x as it is minus 2d divided by 2 e raised to x. Now see, this 2 get cancelled simply, and d of e raised to x. Finally, this is 1 by 2 x e raised to x minus d of e raised to x. D of e raised to x means derivative of e raised to x. And what is the derivative of e raised to x? It is simple, e raised to x. Okay, so my yp in this case is nothing but 1 by 2 x e raised to x minus e raised to x. That's it. Moreover, you can write this as e raised to x upon 2 in bracket x minus 1, because e raised to x is there in the both parts, both terms. Okay, so this is my yp. See how simple it is. So you just have to follow the step by step solution. Okay, you will definitely get the answer. And this method is very simple. If you see, there is no integration, there is no derivative in these all cases. So there are only 6 cases related to this that are useful for our solution. Okay, with the help of shortcut method. So if the function is other than all these 6 cases, okay, suppose if function is like this, if fx is equal to tan x, then what? We cannot use the shortcut method. So in that case, either we have to use the general method, or we have to use the method of variation of parameter. Okay, okay, keep this in mind. So if the function is not in our range, if the function is not related to all these 6 cases, then we cannot able to use this case, use this method of shortcut method. So in that case, you need to use the either general method or method of variation of parameter. Okay, so this method is not applicable for this type of function. Hope you have got this. Is there any doubt related to all the 6 cases? If you have, then please ask. Otherwise, we will move to the general examples related to this method. Okay, is there any doubt? Yes, speak up fast. If there is no answer, then I will just move forward. Okay. Okay, fine. So let us see the next. See, these are the common examples, some common examples related to this method. So just a minute, let me take the one more example for this one. What is that example? See, all this equation. This is a very common example actually. It covers all the things. Let me write this. All it is d square plus 2d plus 1 into y. This is equal to 2 into cos x plus 3x plus 2 plus 3 e raised to x. Okay, so this is the example. Now let us try to solve. We are now interested in the complete solution. Okay, so therefore we just have to find a complementary function as well as particular integral. Okay, for complementary function, consider the auxiliary equation. What is my auxiliary equation? Auxiliary equation is d square plus 2d plus 1. This is equal to 0. So this is a simple expansion of d plus 1 bracket square is equal to 0. So therefore my value of d is nothing but minus 1 comma minus 1. So we have a repeated real roots. Okay, and therefore what is my complementary function in this case? Complementary function is c1 plus c2x e raised to minus x. So we have discussed this complementary function in the separate lecture. So hope you have got that. Okay, how I have written this complementary function for this repeated root. Okay, if you haven't understand, just go through the video. Lecture number 2. I have explained everything. The video is available on the WhatsApp group also. Just the link is available on the WhatsApp group also. Okay, so just go through that. Uh, Now c1 plus c2x into e raised to minus x is the complementary function now for a particular integral. Okay. So next is for particular integral. What is that? Yp is equal to 1 upon phi of d. What is phi of d? It is d square plus 2d plus 1 into function. Now function is this whole part. There the function is divided into three parts. This is one thing is 2 cos x plus 3x plus 2 plus 3 e raised to x. Okay. Now just use the linearity property, separate all these things, because we don't have the combined case for all that things. Okay, we will use that like this. This is equal to 1 upon d square plus 2d plus 1 into 2 cos x, okay, plus 1 upon d square plus 2d plus 1 into 3x. You can take 3x plus 2 in the single bracket also, no problem. Okay, so into 3x plus 2, or otherwise you can just split this two term also. Plus 1 upon d square plus 2d plus 1 into 3 e raised to x. Okay, see, for this we will use case number 2. Okay, for this we will use case number 4, and for this we will use case number 1. Okay, isn't it? So this is equal to what? uh, Replace d square by minus a square. In this first case, replace d square by minus a square. A is nothing but what? 1. Okay, so 2 cos x is there. A is nothing but 1. So therefore it is 1 upon, this is 1 upon d square means minus 1. Replace d square by minus a square. A is 1, its square is 1, and multiply by minus. So this is minus 1 plus 2 into d plus 1. Are you getting this? So this is 2 cos x. 2 is constant. Okay. Then plus. Now what we need to do here? See, 3x x raised to m. The case of x raised to m, x raised to m 1 upon phi of d into x raised to m is equal to, this phi of d goes into the numerator. Its power become raised to minus 1 into x raised to m. Okay. So this, take this into numerator, 1 plus d square plus 2d, okay, into 3x plus 2 is there. Hope you have got this. Now this is the third part, is very simple. Just replace d by a plus 1 upon a is nothing but 1. So this is 1 square is 1 plus 2 into 1 plus 1 into 3 e raised to x. Okay, so this step is very important. We have applied all these three cases here. Okay, now this minus 1 plus 1 get cancelled. Okay, so only 1 upon 2d is there. 1 upon 2d into 2 cos x plus, okay. Now what is here? So this is raised to minus 1. See, we have the expansion of 1 plus y, 1 plus y raised to minus 1. What is this expansion? This is 1 minus y plus y square minus so on. Okay, so this is 1 plus y is nothing but this total bracket. Okay, and therefore say I just use the different color for this. Okay, so 1 minus d square plus 2d. Only these two terms are here. Why only these two terms are here? Because see, next term is d square plus 2d bracket square. Okay, its expansion is d raised to 4 plus 4 times d cube plus 4d square, and into, this is 3x plus 2. If we take the derivative of first derivative of 3x plus 2, what is this? This is 3, and second derivative is nothing but what? 0. So this becomes 0, this becomes 0, this is also becomes 0. So whole thing becomes 0. So that's why we are avoiding all these terms here. Okay, so next terms are not there because the second derivative has, and next derivatives all are 0. Okay, into 3x plus 2. And now what about this? This is 2 into 1, 1 by 4. So this is 3 by 4 e raised to x is here. So this is simple part. Now 1 by 2, this 2 also get cancelled. See, and 1 upon d means integration. Okay, so this is equal to what? Integral of cos x dx plus, what about this? 1 into 3x plus 2. It is nothing but simply 3x plus 2 minus, second derivative of this is 0. plus 2 into first derivative of this is 3. Okay, I have just explained that, and plus 3 by 4 e raised to x. Now we are in the final stage of the answer. Okay, so therefore my yp is simply yp is equal to integration of cos x is sin x plus sin x. This is plus 3x plus 2. 2 into 3 is minus 6, and plus 3 by 4 into e raised to x, and just do that subtraction, 2 minus 6, and that's it. Okay, so 2 minus 6 is nothing but minus 4, and therefore my yp is equal to sin x plus 3x minus 4 plus 3 by 4 e raised to x. Okay, and this is the particular integral, and we are interested in the complete solution. Therefore y is equal to yc plus yp. Okay, and therefore what is my complementary function? C1 plus C2x e raised to minus x, and particular integral is sin x plus 3x minus 4 plus 3 by 4 e raised to x. That's it. Okay, so see, all three cases we have applied: first case, second case, and fourth case. Hope you have got this. Is there any doubt in this example? Okay, if you have, please ask. Yes, are you getting this? Everybody, I think you have got this point. Okay, so fine. Let us move forward for the next question. So d square plus 13d plus 36, okay, is equal to e raised to minus 4x plus sine hyperbolic x. So this is also a simple question. First of all, just find out the complementary function. What is my auxiliary equation here? My auxiliary equation is, it is d square plus 13d plus 36 is equal to what? 0. Okay, now find out the roots for this equation. So what are the roots? Just take the calci equation. Degree is 2, a is nothing but 1, b is nothing but 13, and c is nothing but 36. Okay, x1 is my x1 is minus 4 and x2 is minus 9. Okay, so this means what? Roots are d is equal to minus 4 comma minus 9. Just try to find out the roots. Okay, with the help of calci. So therefore my yc is nothing but, here roots are real and distinct. So c1 e raised to minus 4x plus c2 e raised to minus 9x. Okay, so this is my complementary function. Hope you have understand. Okay, now let us move forward for the particular integral. So my particular integral is yp is equal to 1 upon phi of d. It is d square plus 13d plus 36 into e raised to minus 4x plus sine hyperbolic x. Okay, now same as that of previous, we just split the this term into two parts. Okay, use the linearity property. This is 1 upon d square plus 13d plus 36 into e raised to minus 4x plus 1 upon d square plus 13d plus 36 into sine hyperbolic x, isn't it? Now for this we use the case number 1. Okay, and for this we use the case number 3, hyperbolic function. Replace d square by plus a square, replace d by a. Okay, so therefore we are replacing d by a. 1 upon, this is minus 4, so minus 4 square plus 13 into minus 4 plus 36 e raised to minus 4x plus, now replace d square by plus a square. So what is here? A is 1. 1 upon, it is 1 square means 1. It is 1 plus 13d plus 36 into sine hyperbolic x. Okay, so hope you have got this. Now Next term, what is the minus 4 square is 16. Okay, so this is equal to what? 1 upon 16. Then minus 4 square is 16 plus 13, not plus, this is minus 13 into 4 is I think 52 plus 36. And if we do this, what I get, see, this is nothing but, I think case fails here. So 16 minus 52 plus 36, 0. Okay, e raised to minus 4x. Now case fails here. Plus, now what about this term? This is 13d plus 37 into sine hyperbolic x. Now we don't have any d in this second case. We want d square, only d is there. So just take the rationalization. But here case fails. For this case fails because phi of minus 4 equal to 0. Therefore, in this case, if case fails, then we just take the derivative. Okay, so just take the derivative. This is 1 upon, what is the derivative of d square plus 13d? It is 2d plus 13 into e raised to minus 4x plus, this is 1 upon, is 13d plus 37 into 13d minus 37 divided by 13d minus 37. Rationalization to get the d square in the denominator, isn't it? Now, next is, now replace d by a. So this is nothing but 1 upon 2 into minus 4 plus 13 e raised to minus 4x plus, this is nothing but 13d minus 37 divide by, this is nothing but 13a plus b, a minus b, a square minus b square, a is 13d, its square is 169d square minus the square of 37. What is the square of 37? It is 1369, I think. Check this. Okay, into sine hyperbolic x, isn't it? So now just calculate this. Minus 4 into 2 is minus 8, minus 8 plus 13. So what is minus 8 plus 13? Plus 5. So therefore it is 1 by 5 into e raised to minus 4x plus, now here 13d minus 37 into sine hyperbolic x. Now replace d square by plus a square. A is 1. So therefore 169 into 1 minus 1369. Okay, and that's it. We are in the final stage. 13d into sine hyperbolic x. This is equal to 1 by 5 e raised to minus 4x plus 13d of sine hyperbolic x minus, this is 37. Okay, so minus 37 into sine hyperbolic x. Okay, and divided by, what is 169 minus 1369. Okay, so this is 169 minus 1369 is equal to minus divided by what? This is minus 1200. Okay, just a minute. And this yp is equal to, just we are in the final stage of the solution, yp is equal to 1 by 5 as it is e raised to minus 4x plus 13 into derivative of sine hyperbolic x is nothing but cos hyperbolic x minus 37 sine hyperbolic x divide by minus 1200. See, for this minus 1200, this plus minus become minus. So take this minus 1 to 0 0, and that's it. This is my particular integral. If we are interested in the complete solution, so therefore y is equal to what? Yc plus yp. What is my yc? C1 e raised to minus 4x that we have in the earlier step. See this one. Okay, y c1 e raised to minus 4x plus c2 e raised to minus 9x plus 1 by 5 e raised to minus 4x minus 13 cos hyperbolic x minus 37 sin hyperbolic x divided by, this is bracket actually, divided by 1 to 0 0. Okay, so this is my uh, complete solution for the given differential equation, nth order linear differential equation. So hope you have got this. Is there any doubt? Everybody got this? Yes. So doubt असेल तर please विचारा. Don't just listen it. Don't just on the lecture and put the mobile aside. Okay, don't do that. Just involve properly. Okay, if you haven't understand, Devesh, are you understanding? Okay, Devki, Devki is there. Are you getting? Okay, fine. Okay. Now let us move forward for the next question. We'll solve some examples. D square plus 2d plus 1 into y x e raised to minus x into cos x. See, this is the product of all these three things. Okay, so how we can do this? So let us see this. First of all, just find out the auxiliary equation, and with the help of that, what is the complementary function? So this is d square plus 2d plus 1, this is equal to 0, and therefore roots are minus 1 because this is the d plus 1 bracket square. So therefore my yc in this case is complementary function is c1 plus c2x e raised to minus x. This is my complementary function. Okay, now just move forward for the particular integral. So my yp in this case is 1 upon d square plus 2d plus 1 into x e raised to minus x into cos x. So either you can take x into e raised to minus x cos x, we can use 6 case, or e raised to minus x, x into cos x. We can use a fifth case. Both the ways we have, but instead of doing this, we will do this because it reduces our calculation. The choice is yours. You can do anything uh, out of these two. Okay, so my e raised to minus x outside, I am replacing d by d minus 1 bracket square minus 2 into d minus 1 plus 1 into x into cos x. Okay, so if you have got this step, we are replacing d by d plus replacing d minus 1. Okay, this is equal to what? E raised to minus x as it is. Now the expansion of d minus 1 bracket square is nothing but d square minus 2d plus 1. This is minus 2d minus minus plus 1. So not minus 2d, this is plus 2d. This is plus and this is minus 2 plus 1 into x cos x. Okay, see what is happening here. So minus 2d plus 2d get cancelled. This 1 plus 1 is 2 and it cancel with this minus 2. So only d square is there. Only d square is there. Okay. So this is equal to e raised to minus x. This is 1 upon d square into x cos x is there. Now one more time use the 6 case now, x into v. Okay, so x into v is cos x. Therefore, e raised to minus x in bracket x minus derivative of phi of d, it is 2d divided by d square into 1 upon d square into cos x. Okay, Fifth case we have used. Now it become e raised to minus x minus 2d upon d square into, now second case, replace d square by minus a square. A is 1. So this is 1 upon minus 1 into cos x. So this term become minus e raised to x because of this minus, in bracket x into cos x multiply by cos x. This is 2d divided by d square into cos x. Okay, again use the second case for this. And what I get, this is minus e raised to x in bracket x cos x minus 2d divided by minus 1 into cos x. Replace d square by minus 1. Second case. Okay. So d square by minus 1. Now minus minus become plus. This is minus e raised to x in bracket x cos x minus minus become plus 2 into derivative of cos x. What is the derivative of cos x? It is minus sin x. Okay, and my final answer for this is yp is equal to minus e raised to x in bracket x into cos x minus 2 into sin x. That's it. This is my particular integral. And if we write the complementary, so complete solution, so therefore y is equal to what? Yc plus yp. Okay, and this is nothing but yc is c1 plus c2x e raised to minus x plus yp is nothing but minus e raised to x in bracket x cos x minus 2 into sin x. Okay.